all yours.
Hello, hello. So we are here to talk a little bit about Headless for humans, and it could as well be called managing complexity, because that is part of what we need to talk about. The reason it's called managing complexity and for humans is that, well, it's easy to relate to. We are all humans, but mainly because technology is human-centered, right? We talk a lot about architecture and design and implementation. We tend to forget that every single one of those decisions behind the code is made by a human, every implementation is made by a human, and they are all managed by all of us. So implicit in all of that are all the decisions that we make to get to that point and how it's managed. And so we need to talk a little bit about that to understand how to do headless well, because it's a choice, it's a trade-off, and implicit in that, there are a lot of things to think about, right? You can do a monolith well, you can do headless badly. Let's discuss how we can do headless particularly well to take advantage of it in the best way possible. Before I do that, a quick shout out to Algolia, because they're the reason I'm here, thanks to Netlify as well, and they're actually super cool. So if you have documentation, for example, if you've ever visited the React documentation or Vue and stuff like that, you've used Algolia. If you have documentation, you can get on Doc Search for free. If you have an open source project or you have a community project, I know there are a lot of creative people here in the room, you can also make use of it for a discount or for free. And on top of that, there's obviously the paid for service, which is incredible in itself. But yeah, plenty of community support. So why are we talking about this, and why am I talking at you about it and hopefully with you in a moment? Well, it's because we have a great opportunity ahead of us. We're working in a space where experiences have become much better, but they still have a long way to go. If you look at some of the benchmarks, which we heard earlier from the Netlify keynote talk, we still have a lot of work to do in web. And we're still working around different frameworks and different cohesive ways to achieve things. So we have a ways to go, but we can get there. The second is related, is that we're working with systems, right? Systems have components, interrelated parts, and they're not easy. If you want to know a little bit about me, I started at Twilio and then helped build Molten, which was a commerce API, and now at Algolia. And it's not been easy from the get-go. It never will be. So that's why we should do it together. And the second is that the timing is right. As you might have heard, or as you might have thought yourself, there's generally a constellation of innovations which make leaps forward happen. And generally, there's some limiting factors in that constellation. And so we're reaching a point where those limiting factors are being breached. Things like computing power and obviously developer experience, we're getting to a point where we can do much more with less. So now is the time. Let's talk about how we can do things. So this is a false dichotomy. It's a provocative question, but there's a good reason for it. So if you ask yourself, and I'm going to have to ask myself rhetorically because I can't hear your answers, which is better, a simple flexible system or a complicated flexible one? Simple inflexible? Well, there's a reason we ask that question, because implicit in every system, there are parts. The more parts you have, the more complicated it can become. If you keep it simple, you can reduce the number of parts, but as we'll see in a moment, it's hard to keep it completely flexible when it's simple. So that's the reason we have bundles. Everything gets bundled up and standardized. That's the reason it's hard to build, let's say, GUIs on top of very flexible interfaces, because that has to be standardized. So the more flexible we have, the harder it is to keep things simple. And that's a premise in code as well. And it's going to become important for headless, as you'll see in a moment. If you want to know what side we need to end on in this trade-off of simplicity and complexity, we need to be adaptable. That's what we heard today. So every chance we have to iterate faster and be adaptable according to things changing in our environment and with customers, that's a good thing. So we should really side on trying to make flexibility simple. We need to try and be as flexible as possible, but keep it simple so that things don't come complex. This is why. So here's the trade-off we have, right? I'm going to ask myself, and you ask yourself, it's an obvious question, but it's important. Which of these shapes, on the left or the right, is it easiest to add to? And so here in the left, we obviously have the same shape, and they're directly connected. They have an interface to each other. So in fact, it's very easy to add to this. You can add things at the top or the bottom. They're directly interfaced, but they must be the same shape. The connection must be similar. Now on the right, we obviously have 3 different parts, so that's one more than on the left. But if you want to add to it, you can add any kind of shape. Now there's a reason there's a block in there in the arrows, not just arrows, because we're going to talk about the moment, where does the complexity lie on the right? In the left, it lies on the connection. In the right, it lies between those arrows. And that's very important because you're going to deal every day with the arrows. The data flow and the connections in Headless, it becomes very important and you need to manage it well. So in summary, we have something which is easier to change, something which is more simple, but possibly harder to change because they're directly connected. This is why headless systems and unbundling is good, right? So when you have specialized components, you can have best of breed stuff. The more things specialize, which is a natural thing for humans too, where you have lots of different things doing one thing very well. The opposite side of that coin is that the system diversifies. You have many things in one ecosystem which now need to be managed. The flow between them needs to be managed. And we'll see in a moment some of the problems that occur when that happens and how to tackle them. We need to look into the arrows in this case. So the problems that occur is that we have data flow. We have multiple accounts. We have compatibility issues. We have uniformity, so those interfaces. And we have technicality. Can technical users only deploy this solution? How easy is it for the business? There are 3 things you can do about it, okay? So if you want to make flexibility simple, you can work on your company design, system design, and make good strategic choices. It's very abstract, this one. Let's get into it. So with company design, there are 3 areas of focus. In my personal experience, I'm sure you can argue and add more. The first is the interface between engineering and product. The key to the flexibility are your engineering team. It's like putting Thor's hammer in his hand when you have good engineers. The more complex a system becomes, the more you're limiting those engineers and the harder it's going to become for everyone. So the factor which can influence that the most is generally a good technical product team, being the voice of the system that you're building, knowing how it's working, knowing what the limitations are. The second we've actually found is to have a data team, or at least one person or function which is thinking about data cohesively, have it earlier. You see in the system we've got lots of interconnected parts, and we have things like XML and JSON and different kinds of data formats, all piping in imports, exports. Every analytics team knows about this. They're going to want every kind of data that they can get. And if you're using something like Segment or a data lake, it's really important that you have someone thinking about data design earlier than you think, because it's going to matter. The third one is a bit counterintuitive, because one of the benefits of Headless is to go faster. Well, actually, I think it's a common phrase, no? And they say slow is smooth, smooth is fast. It's one of those things where if you take time with your additions to the system, think about how they impact the system, and then make those carefully, you can still do the best thing for your customer, you can still move quickly, but you can build a good system by keeping it simple and having as few parts as you can while keeping them flexible. So that's very important. Slow down your processes and consider the company as a whole. Get your data team in there and make sure you have a really strong engineering product relationship. It's super key. Second, for the system, know your arrows. So it's different from the data flowing between those arrows. It's very important to know what you're using as a message queue, for example. How does data get from one place to another? How does it get from your search engine, to give an obvious example? How does your search engine index your products? What if you have blog content and all of that kind of stuff? Algolia obviously takes care of it. But in your own system, will you have control over it? You heard that earlier. It's a very good thing, but you need to know those things over which you need to have control, and you need to keep them simple. The second is trying to standardize the data that flows between your components or your parts. Work hard if you can to try and make sure that the data flowing is consistent as possible and is as useful as possible. Like, for example, if you're an e-commerce company, you want to implement segmentation. Where do those segments live? How are they calculated? And then you want to add one-on-one personalization on top. Where does that data come from, and is it standard? Can they work together? So this is where data architecture is really important. And then lastly, we have simple, not easy. So it's a very important distinction. Easy generally means that it's, quick to do, whereas simple can mean there are fewer parts which work well with each other. So if someone says, well, this is easy to implement, well, you can actually implement something which is terrible very fast. So it's very important to consider, are you keeping things simple when you implement? And the last, we have strategic choices. So we talked about friendly interfaces. This is because when you have very flexible tools, it's hard to standardize them on a good interface useful for business users. So when you're choosing tools, think about that and think about what's actually usable as well as flexible. Forget the hype cycle. So generally, we've immature technologies, but they could be really good on this trade-off. They could be really good for you. Equally, we've very mature companies who might have a very good, let's say, business-friendly interface, but obviously bad on developer experience. So think about the trade-off rather than just the maturity itself. Finally, we have the cost of maintaining and changing. So it's part of the total cost of ownership, but please consider it, if you would, for your entire system. Not just like, well, if I take that tool out and put this one in, what if you have to change the way the components are interlinked? What if your data flow changes? And what if you need to use a data lake and that kind of thing? So look at what it costs to maintain in and of itself, but the cost of change. Not that you will have to, but it's very important to know. So those are some tips, and hopefully we all understand the problems that come with Headless, but the opportunity to do it well is absolutely huge. Thank you, guys.